Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about optocouplers interface with microcontrollers. So optocouplers, so this will be most useful for interfacing some high voltage devices to the microcontrollers. So because we need to completely isolate the high voltages to the microcontroller or an electronic circuits. So release is one of the devices. So better than that, the optocouplers can be used. So release still we have a neutral connections in between. That is ground connection is interconnected with microcontroller and high voltage. So here completely this is isolated. So only this optically it will be coupled and electrically it will be isolated. So this is the concept of optocouplers. So it will be optically this will be coupled by using this solid state relays, but electrically it will be completely isolated. Look at this diagram. So this is the look at the diagram. Look at this. So from microcontrollers that will be connected here only. So this is the actual optocoupler. So here for example I am connecting from a switch. Look at this is switch and we have an on resistor and that will be connected to the LEDs. So what happens actually, so this is the phototransistor and this is the LED. So once this LED glows, there is a no electrical connection from this part to this part. So this is the input side and this is the output side. So this is the electrically 100% this will be isolated. But this is optically connected. How it is possible? Look at this. So once this LED glows, so this illumination will be interfered and this will be put on this base. Once this light falls on here, so it generates the base currents. So once the base current is get, the transistor become turn on. Once this transistor is turn on, what happens? So the load is connected to the supply voltage. Look at this. This is supply voltage and this will be connected to load and that will be connected to transistor. Once the transistor is turn on, what happens? This load is connected to the supply voltage. So if you take a higher voltage, 230 voltage AC or any higher voltages, so that will be connected to the load. Look at this, this is completely eliminated. So look at this, this is the input side and this is the output side. Look at this, electrically there is a no connection, even ground connection there is no connections. So completely isolated for an electrical connection. So this is optically coupled because so this light should be fall on this base. Then only we get a base current and this base current can turn on this transistors. So this is an optocoupler basic principle. So we use LED here and we use these phototransistors. We can use a phototransistor or a photodiodes for this. So this is completely put inside a single chip. So we won't see inside this because the outside illumination may fall inside this. So it may turn on the lights. That's why this is completely sealed. So once if we turn on this, so this light cannot be visible to our. So this will be completely closed. Look at this, how it will be connected to the microcontroller circuits. Look at this, I am taking the microcontroller 8051, I am taking this port 2. So taking this port 2.6 pin and taking one resistor and that will be connected to the our optocouplers. Inside this we have an LEDs. Look at this. So once look at this, this will be connected to anode and cathode will be grounded. So once if we give a 1, so this transistor, this diode will be turned on. So this LED will be closed. Once this LED glows, what happens? So this transistor becomes on. Once this transistor becomes on, what happens? So through this another transistor we are going to turn on this. So once this transistor is turned on, this motor will be starts rotating. So here I am using this 2K resistor. This is a pull-up resistor. Pull-up resistor means if there is a no output, it will be maintained as a high. Look at this. So here this will be connected to this 2K resistor and that will be connected to the base of this transistor. What happens if there is a no output like a high impedance state? What happens? This one will be connected to this base, so this transistor will be turned on. So once if it is a 0, this will be turned off, else it will be on. So that's why I am taking this pull-up resistor here. So we can use this as a both configuration, common anode or common cathode. So here I am cathode is connected to ground. Instead of this, I can connect this anode to 5 voltage and cathode can be connected to the port 2 pin. What happens? If I give a 0, that LED will be closed. So here if you give 1, because this is connected to anode. So here if we give a 1 and this 0 is already connected to cathode. So once if you give 1, this transistor, this LED will be closed. Once this LED glows, this transistor becomes on. Through this transistor, what happens? Look at this. Once this is on, so this ground voltage will be connected to this transistor. So what happens? So this will be turn off. So what happens? So we can turn off it. So we can configure both turn on and turn off depending upon the requirement. So we can use NPN transistor or PNP transistors. So here I am using this NPN. Instead of this, we can use PNP transistor also. Again, we can use different switching modes and other possibilities also. So this is one of the best usage for an optocouplers, because so completely isolated. Look at this. So this ground is completely isolated from this ground and this ground. So what happens actually? So completely this will be eliminated. So no surge voltage or a leakage current, it will be passed from a higher voltage circuits to our microcontrollers. So here I am mentioning it's a 24 voltage. Instead of this, we can use a 230 voltage AC or even 440 voltage. So depending upon this, we need to use a higher rated transistors. So no optocouplers to be changed, because electrically there is no connection. So this is only connected through the optical medium only. Thank you.